Okay, so the next operation on a pointer is assignment operation. Okay, so let's quickly discuss about the assignment operation on the pointer. See, we have already discussed about the assignment operation on the pointer in our earlier videos. Okay, so let's write a simple code snippet. Let's assume we have a variable of type int and it is having initial value as 10, and we want to create a pointer to this variable. So how we used to do it? We used to write int star followed by ptr, it is name of the pointer, is equal to and a. Now this operation is nothing but an assignment operation. We call it as initialization, but initialization is nothing but an assignment operation. It is just having a special name called as initialization because this assignment is done at the time of declaration of the variable. Okay, so this is nothing but an assignment operation. So what we are doing, we are creating a pointer, and in that pointer we are assigning some value. In this case, what is that value? It is address of a variable. Okay, now one question, can we reassign some new value to this pointer variable? Let's assume that there is one more variable, let's say with name b, and it is having value as 20. Okay, now what I want to do, right now in ptr we have address of a variable, right? What I want to do is I want to store address of b variable in ptr now. Okay, so can we do that? Yes, we can do that. We can assign a new value to ptr variable, and that can be done. So what we need to do, or what will be the syntax? It will be very simple. See, we have to write ptr is equal to and b. See, here we are declaring ptr, and at the time of declaration we are assigning value as address of a, right? But in future, if you want to change the value present in ptr pointer, then you can do that, and you can do it like this. So I am writing ptr is equal to and b, and that is fine. Okay, we can write that. Now one important thing. So let's say we have a character variable. Let's say its name is c, and let's say its initial value is small a. Okay, now the important question here is, can we assign address of c into ptr? Can we write something like this? Will it be a valid statement? Can we write it like this? This is something which we have to discuss. See, c is a character type variable. It is having initial value like small a. ptr is of type int star. Okay, so what we are doing is we are trying to store address of a character type variable into a pointer of int star type. Now when we say pointer is of int star type, that means basically it is made to point to an integer variable or integer data type variable. But in this case, what we are trying to do, we are trying to assign a value which is of type, or which is an address of a character variable. Okay, and let's see if it is possible. So let's quickly go to the VS Code and let's see it in action. Okay, so we have ptr. Okay, so what we'll do is we'll create another variable, that is b. Let's initialize it with 20, and what I have to do is I have to assign address of b into my ptr variable. So for that I'll write ptr is equal to address of b. Okay, now after writing ptr is equal to address of b, okay, after doing this, if I write cout star ptr followed by endl, let me just change value of b. Right now it is 20. Instead of that, let me make it as 30. Okay, so what I am doing is I am assigning address of b into ptr. Okay, and after that, when I will write cout star ptr, what will be the output? Its output will be 30, right? Because right now ptr is pointing to b variable, and b variable is having value as 30. Okay, so the memory location to which ptr is pointing right now, it is having value as 30. That's why the output of dereferencing will be 30. Okay, so let's quickly execute this code. Let's quickly see whether we get 30 as the output. So let's compile it first and let's run it. You can see that we are getting 30 as the output. Okay, so it is working perfectly fine. Now let's discuss about the next use case. Let's say we have a character variable with name c. Let's say it is having initial value as small a, and what we are doing now is we are writing ptr is equal to address of c. We have to see whether this is possible or not, whether it is allowed by C++ compiler or not. So for that, let's go to the terminal and let's compile this code again. Okay, you can see that we are getting an error. We are getting a compile time error. You can see that the compiler is saying cannot convert char star to int star in assignment. Okay, now what exactly this means? See, whenever we write address of any variable, whenever we write in here, you can see whenever we are writing and C, that means address of C. So what is data type of this thing? So data type of this thing is going to be char star. See, addresses will be always of type data type followed by star. So whenever we are writing address of a character variable, or whenever we are writing and of character variable, so its data type is going to be char star. Whenever we are writing and of integer variable or address of integer variable, its data type is going to be int star. Okay, and what is data type of this PTR variable? Whenever we have declared this PTR variable, we have declared its data type as int star. So data type of int star, so data type of PTR is int star, and data type of this thing on the right hand side is char star. So basically what we are trying to do is we are trying to assign value of type char star into a variable of type int star, and the compiler is saying that it is not allowed. Okay, so that means we cannot assign address of any different data type into a pointer of another data type. Okay, so in this case we are trying to assign address of a character type variable into a pointer which is made to point to an integer variable, and that is not allowed in C++. Now there is one important thing that is not allowed in C++ implicitly, but you can do it in C++ explicitly. Now what do I mean by explicitly? See, remember we have to discuss about typecasting when we discuss about the data types. So what we can do is we can tell the compiler explicitly that I want this char star address, or I want the address of this character variable to be stored in this PTR. I want to do this, right? We can explicitly tell the compiler with the help of typecasting. And I hope you remember the syntax of typecasting. Whenever we have to typecast any data type into any other data type, what we have to do? We have to write in parenthesis the new data type, or the data type in which you want to convert. So in this case, and C is of data type char star. Okay, so what we have to do? We have to convert this char star into int star, because PTR is of type int star. So what we'll do is we'll write in bracket int star over here. So whenever we write int star over here, that means we are telling the compiler explicitly that I want address of C, which is of type char star, to be converted into a data type called as int star. Okay, and as the char star getting converted to int star, now the address is compatible with PTR. Okay, so now if I will compile the code, you can see that the code gets successfully compiled. So let's move to the whiteboard and let me explain you what is exactly happening over here. Whenever we write PTR is equal to int star in bracket int star and C, what is exactly happening? So let's quickly move to the whiteboard. So we have a pointer that is PTR, and it is now pointing to C. Okay, and C is of character type. So let's create one variable over here. Its name is C, its initial value is small a, and let's assume that its address is 100. See, our address is always going to be 100. This is kind of standard whenever I will give any example. Okay, so you know how the addresses look. It is just for the example purpose. Okay, so don't take it too seriously. So we have C variable. Now what we are doing is we are creating a pointer that is PTR. It is actually already created, and what we are doing is we are assigning address of C into the pointer, and we are doing typecasting for that. Okay, so before this we can't directly write PTR is equal to and C. So what we are doing, we are writing PTR is equal to in bracket int star followed by and C. So we are explicitly typecasting char star data type into int star data type. So what is value present inside this PTR? It is 100. So we are saying that PTR is pointing to C. Now I have a small question for you. Just tell me, just think about it, take a pause and think about it. What will be the answer of this statement if I write cout followed by star PTR? What will be the answer? Just try to think about it. Okay, so if you are thinking that the answer of this question or answer of this statement will be small a, then you are wrong. Okay, the output of this statement is not small a. Okay, if you are thinking that its output is 65, it will be 65, as 65 is an ASCII value of small a, then also you are wrong. Okay, so what is the correct answer? The correct answer is we cannot predict what will be the output of this statement. We can't really predict what will be the output of this statement. So let me explain you why we are not able to predict the output of this line. So for that, I have a small diagram at the top of this whiteboard. You can see over here I have drawn a RAM. So what is RAM? RAM is nothing but sequence of bytes, and every byte is going to have an address, right? So let's say this byte is having address as 100, this is address 101, then this is 102, and this is 103, okay, and so on. Now our variable C is present over here. You can see this memory location, that is 100. This is where our C variable is lying. Now C variable is of character data type. So what will be the size of C variable? It is going to be 1 byte. Okay, so this is the only byte in which the content of C is available, right? Now tell me, what is the data type of this PTR variable? Data type of PTR variable is int star, right? So whenever we write star PTR, what exactly happens in the background? How compiler actually gets the value at that memory location and give it back to us. So let me tell you how the compiler operates. Whenever we write star PTR, what compiler will do? See, what compiler will do is very simple. Compiler will check what is type of PTR. So what is type of PTR? Type of PTR is int star. That means the compiler will now know that PTR is a pointer to integer variable, right? Because type of PTR is int star, that means compiler can figure it out that PTR is actually made to point to an integer variable. That means the PTR, whatever address that is present in PTR, that will be an address of integer variable. This is something that the compiler will assume. Okay, now we all know that integer variable takes 4 bytes of space in the memory. This is something which we all know. Integer takes 4 bytes of memory. Okay, and as PTR is of type int star, whenever we write star PTR, the compiler will assume that PTR is pointing to an integer. So whenever we are writing star PTR, what compiler will do? Compiler is now having address inside PTR, which is 100 in this case. So what compiler will do? Compiler will go to the 100 memory location, and from 100 memory location it will fetch next 4 bytes. These 4 bytes, next 4 bytes. Why it is fetching next 4 bytes, or why it is taking the data from next 4 bytes? Because it is assuming that the data or the pointer is pointing to an integer variable, and we all know that integer takes 4 bytes of memory. That's why the compiler is fetching value from the 4 bytes. Now we don't really know what is present in these 3 bytes. We don't know, and we can't say what will be there in these 3 bytes. And that's the reason what compiler is doing is it is fetching value from these 4 bytes, it is converting it back to the integer and then giving it to us, and that's why we can't really say what will be the answer, because we don't really know what is there in these 3 bytes. And now I think now you have got an idea how the dereferencing operator actually works. So what compiler is going to do? Compiler is getting an address. Compiler is going to go to that address. Compiler knows the data type of the pointer, so compiler knows how many bytes it has to dereference. Okay, so if it is an integer pointer, then it will dereference 4 bytes. If it is a character pointer, it will dereference only 1 byte. If it is a float pointer, it will dereference again 4 bytes. If it is a double pointer, then it will dereference 8 bytes. If it is a long pointer, then again it will dereference 8 bytes. So it depends the data type of the pointer, and on that the compiler will decide how many bytes it has to dereference. Okay, and that's the reason even if we are having address of C, we can't really perform any operation on this memory space, because whenever we are going to do any dereferencing, it will work or it will happen on all these 4 bytes. We can't really access this only single byte. Okay, that's why the C++ language doesn't really recommend you to do explicit typecasting. Okay, but there are some scenarios where actually you have to store addresses by doing explicit typecasting. Okay, but I don't think that we should go in that much detail and discuss about all those scenarios, because those scenarios are very low level scenarios, and they are operating system related or system related. That's why let's not discuss about them. But now I hope that you have got a basic idea about how the explicit typecasting works, and how the address that we are storing is actually not of much use because of the way C++ is doing dereferencing operation. Okay, now let's quickly move to the VS Code and let's see what exactly we are getting as the output of this thing. Okay, so let's go to the VS Code. Now what we'll do is we'll just print value of star PTR. Let's see what we get as the output. Let's compile this code again and let's execute it. Okay, you can see that we are getting some random value 777, 4 times 7s. Okay, this is something unpredictable. I mean, we cannot really predict this value, that is 4 times 7. Okay, so this is something which we were talking about. This is a random value which we cannot predict. Now, is there any way, this is one interesting question, this can be an interview question. Okay, so is there any way by which I will be able to print small a on the screen with the help of PTR pointer? Just try to think on it, just take a minute, just try to think on it. Is there any way by which we will be able to print small a on the screen with the help of this PTR pointer? Answer is yes, there is one way. How we can do it? Let me show you. See, what is type of PTR? PTR is of type int star. As it is of type int star, while dereferencing, compiler is dereferencing 4 bytes. So what we'll do is we'll typecast this PTR which is of type int star into type char star. So what I'm doing, I'm writing char star in front of PTR. So what will happen? See, PTR is of type int star, so int star will be now converted to char star. And once we have a converted address in type char star, or once we have a converted pointer in type char star, then we will apply dereferencing operation to it. So instead of directly writing star PTR, what I am doing is I am writing star, then in bracket char star and then PTR. So what will happen? PTR is of type int star, it will get converted to char star first and then we are dereferencing it. So now as we are dereferencing a character star pointer or character star type, because it is getting converted, typecasted, explicitly getting typecasted, now the compiler will dereference only 1 byte because now it is of type char star. And now as it is just dereferencing only single byte, so we'll get value of small a. Okay, so let's do it. So let me just write cout followed by endl. Okay, and now let's compile this code again and let's run it. Okay, so you can see that we are getting small a as the output. Okay, so in this way you can get the small a as the output, but ultimately what you are doing is you are creating integer pointer, you are storing address of character variable in it, and then while dereferencing again you have to convert it back to the character pointer and then you have to dereference it. Instead of that, why don't you create a character pointer? Instead of storing address of C in PTR which is of type int star, why don't you create another pointer of type char star and store addresses in them? Doesn't make any sense of storing address in PTR which is of type int star. Okay, so that's the reason whenever you want to store address of any variable, create a pointer of that particular type. Don't do it like this. Okay, it is just a workaround. You just have to use such things whenever there is a high need or such kind of use case, which we are not going to discuss in this module or in this course because it is very low level thing. Okay,